Okay, so 3.1, 3.5, no calculator. Number one, what is the average rate of change? So average rate of change is slope of the secant line. There's no derivative or anything going on with that. So that's going back to middle school, if not earlier, finding the slope, change in y over change in x. So in this one, we should end up with a negative 4 pi. Number two, so this one, they give us two functions. All right, they give us a piecewise function. Let f be the function given above. Which of the following statements are true about f? So the first one, it asks about a limit. Well, let's just give a quick sketch to see what's going on here. So x plus 2, I know that's linear for values of x less than 3. And so it's going to look something, it's going to cross here at 2. It's going to look something, and it's less than or equal to. So it's going to look something like that. That's the first piece. And then 4x minus 7 for our values of x greater than 3. Well, it's a slope of 4 compared to a slope of 1. So this one's going to shoot up a little bit steeper. I'm exaggerating it. It's not completely vertical, but it is going to shoot up steeper. So this would be my piecewise function. Part 1, the limit as x approaches 3 of f of x exists. Yeah, this is true because it's approaching the same spot. So 1 is true. 2, f is continuous. Yep, it's continuous because 1 was less than or equal to 3, 1's greater than 3. 3, f is differentiable at x equals 3. No, it is not differentiable there. We have a corner going on. So in this one, it's only 1 and 2, so letter D would be the correct answer for this one. Number 3. So number 3, we need to recognize that this is asking for the derivative of sine at pi over 3. So from all this notation, we need to recognize that this is asking for derivative. The function we're working with is sine, and the value, theta or x, however we want to think about it, is pi over 3. So we need to do the derivative of sine of x, which is cosine of x. And then we need to evaluate cosine of pi over 3. So cosine of pi over 3 on my unit circle is going to be up here. Cosine is 1/2 root 3 over 2, or the coordinates are. And cosine is the x value. So this becomes 1/2. Number 4, working with a piecewise function again. And in this one, we have 3x plus 5. And so we thought of it graphically, 3x plus 5 for values of x less than negative 1. So it's going to look something like that. It's going to be a straight line. But then when we cross negative 1 for an x value, it turns into a parabola that opens down. And so now we have a parabola opening down from here. And so we had a straight line going into a curved line. That is not a smooth transition. Okay, so it says if f is the function defined above, then f at negative 1, right here at negative 1, it is not differentiable. It's not differentiable there. It's not a smooth transition. Okay, it's going from a linear to a parabola. It's not that smooth. Going parabola to parabola, nothing we can work with. So this one would be letter E. It's non-existent. Number 5, if y equals x sine of x, then the derivative is product rule. So this is letter B, sine of x plus x cosine of x. Now into the free response. So they give us this graph, and then they give us a table of values. Part A, approximate the value of f of 5. All right, so we have a graph going on kind of like this. We got an open circle, closed circle, and then it continues on. Here is at 5. So it wants to approximate the value of f of 4.5, f prime at 4.5. So f prime at 4.5, here's 4. At 4.5 would be right about here. So f prime of 4.5 would represent the slope of this tangent line. That's what it's asking me to find. To approximate the slope of that tangent line, since it's an approximation, I can pick 2 points. And I want to pick 2 points close to 4.5. Well, I'm not going to choose 4 and 5 because 5 is way down here now at the bottom. So if I did a secant line, it's actually going negative. It's going down. So if I pick my 2 points as just here at 4 and here also at 4.5, and I drew a secant line there, I mean, that's pretty close to my red line. Okay, that's me. So we want to choose the points. We want to choose f of 4 and f of 4.5 from the table. We don't want to choose f of 5 because f of 5 drops us down to that lower line, and that's not an accurate representation anymore. So we want to choose 2 points near it that make sense. So 4 and 4.5 are in the table, and we can go from there. So when we do this one, we end up with 1.32 when we chose those 2 values. B, is there a value of x for between 0 and 5 such that this limit notation equals 0? Well, that limit notation is really asking us about the derivative. So what this is saying, is there a value of x on this interval from 0 to 5 where our derivative is equal to 0? Yep, there's one spot that's just going to happen at. Be right about here, and it comes out to be 2. But right there, I have a horizontal slope. My derivative is equal to 0. So I want to see something that you recognize this notation is asking about when the derivative is equal to 0. And then you're telling me that it happens at 2 would be sufficient. And then C, for each of the following limits, find the value or explain why it does not exist. And again, it is actually asking us about a derivative. It is not a limit. So this is limit notation saying, well, what is the derivative at 5? So right here, the derivative at 5, my diagram here is getting kind of messy, but we can see there's a jump discontinuity going on at 5. So there's not a derivative at 5. Does not exist. Okay, our graph is not continuous. There's a jump discontinuity. Derivative does not exist. Don't tell me anything about limits from left and right. I don't need to know anything about limits. That limit notation is asking us about the derivative. What's going on with the derivative? And then 7, use data in the table to approximate C prime of 3.5. The copying of this didn't come out very clear. If any time on a test you don't understand what is being asked, or if there's kind of a typo, or you can't understand the notation, because somebody said, well, I thought it said C double prime. Do not ask me, okay? Do not guess or assume what it's saying if you're not 100% sure. So this is C prime of 3.5. So to find out 3.5, I could just choose 3 and 4 and find my slope of my secant line between the two, which ends up being 1.6. And then units. Do not forget units. This is ounces per minute. So they give me T minutes. C of T is in ounces. So my rate of change would be ounces per minute. In that one. Okay, any questions on the no calculator? Let's go on to the calculator side. All right, so with calculator, number 1, let f be a differentiable function. They give us a table of values. What is the average rate of change? Again, that's simply slope. So this is negative 5 over 2. So change in y over change in x. Number 2, the function h is defined on the closed interval. The graph of h prime, the derivative of h, is shown. So they're giving us the derivative graph and asking us questions about the original graph of h. So we needed to catch that they gave us a derivative graph, which simply represents slopes. the values of the slopes. We're not looking at the slope on h prime at all. H prime, this graph is representing slope values of h. Okay, which of the following statements must be true? So they're asking me questions about h at -1 and h of 3, not h prime of -1 and h prime of 3, simply the functional value. I don't know anything about h. I only know slopes of h. I don't know any functional values, so I can't say anything about number 1. Number 2, h is continuous at x equals 1. Yes, this is true because it's on my graph. It's a defined point. So there is a slope at 1. I can find the slope of a tangent line. So therefore, it had to have been defined. It had to have been continuous on the original graph h. And then 3, the graph of h has a vertical asymptote. The graph of h prime looks like it has a vertical asymptote, but we don't know anything about the graph of h. So we can't say anything about number 3 being true. So only one we can confirm is number 2, so that'd be letter B. 3, of these intervals on which f is continuous but not differentiable, it's only from 2 to 3. So letter C, and that's an interval, that's not a coordinate point. So 2 to 3 is interval notation. I have a cusp going on there. It is continuous, but it's not differentiable. Number 4, for any function, which of the following statements must be true? So this was left off for some reason, didn't print out, but it's saying the limit as x approaches a of f of x equals f of a. So number 1, if f is defined at x equals a, then the limit must be equal to the functional value. No, that's not true. We've talked about that over and over. Okay, I could have something that looks like this. All right, and I could have maybe my value down here or something, where my limits do not equal the actual functional value. But 2, if f is continuous at x equals a, then they must be true. Yes, because if it's continuous, now I have no holes in my graph. So my limit must equal my functional value if this was a. And then 2 ties into 3. If f is differentiable, if it's differentiable, it had to have been continuous. So if 2 is correct, 3 also has to be correct. Okay, number 5. Table above gives values of the differentiable functions f and g and their derivatives at x equaling 1. It says if h of x, so this is number 5, h of x equals 2 times f of x plus 3 times 1 plus g of x. And it wants us to figure out, well, what is h prime at 1 then? So we should recognize that we have product rule going on here. If we want to figure out what h prime of x is, we have to use product rule. They don't tell us what the actual functions f of x and g of x are, so we don't have to do any power rule, we don't have to do any quotient rule, we don't have to do any of that stuff to figure out how to evaluate these actual derivatives. If my function's f of x and they're asking me about the derivative, I know it's f prime of x. This is constant multiple rule, so it's 2f prime of x plus the derivative of 3, which would just be 0. So I'm going to do the derivative of this first one, the other one stays, plus my derivative of the other one, which would just be g prime of x, times my original that stays. So we need to become comfortable or more comfortable finding derivatives kind of in a simpler form, where if it's, okay, if they tell me it's f of x, the derivative is f prime of x, and I'm done. I don't have to do anything more from that. Now that I have my product rule actually laid out, I can do it at h prime of 1. So this is 2 times f prime at 1 times 1 plus g prime at 1 plus g prime at 1 times 2 f of 1 plus 3. I'm simply putting in 1 for all my x values. Now I can actually look at the table and start to fill in. So f prime at 1 is a -2. G of 1 is a -3. G prime at 1 is 4. F of 1 is 3 plus 3. Now I have all of my numbers in for each function. Right? The benefit of them giving us the table is they're essentially giving me the answers. I don't have to do any math, but I have to do the calculus to understand, okay, how do these all fall into place? So when you work all this out, you should end up with 44. So letter D would be the correct one on this one. And this is a common AP type problem. You're going to see more and more and more like this, where they'll give you a table and you have to put in values or find your values when you're doing your workings from that table. Number 6 says use the data in the table to find an approximation for R prime at 45. And so we can look, well, if we're going to at 45, we can look at 50 and 40. Those would be the two closest points, and that would give us an approximation of what it would be at 45. But the thing I want to pay attention on this one is going to be the units. So in the table, they say T is in minutes, but R of T is in gallons per minute. So we're trying to find a rate of change of gallons per minute. And so this one ends up being 1.5 gallons per minute, or you could just say 1.5 gallons per minute squared. So if you didn't give me any units, I took a point off. If you wrote it just as gallons per minute, I gave you the credit for that, and I probably put a little squared on your minutes, but make sure you're paying attention using the correct units. The original rate was a gallons per minute, so we want to find the rate of change of that, gallons per minute per minute. And then the last question, they give us a table, and there's a whole bunch of stuff we have to figure out. A, using the values of G, estimate G prime of 5. So in this one, we can just take 2 points around it. So G of 6 and G of 4, the change in Y divided by the change in X, 6 minus 4, to end up with a -3/2. So this is probably the 4th problem on this test that I've asked something about average rate of change. B, we have subtraction f of x minus g of x. So the derivative of that would be f prime of x minus g prime of x. Okay, so r prime of x is f prime of x minus g prime of x. All right, so this is 7b. We're ultimately going to do it. They want to know what r prime of 2 is. So this is f prime of 2 minus g prime of 2. G prime of 2, I can look right at the table. G prime at 2 is 4. Now f prime of 2, well, they told me my function f of x was x sine square root 3x squared plus 5. Now that we know chain rule, we could come up with a derivative function, but we're trying to figure it out right here at 2. We can just put that in calculator. So we did a couple practice problems leading up to the test that if they're asking us to find a derivative at a point, we can simply put that right in the calculator, and it'll tell us when we do this, f prime at 2 is a -2.449. So -2.449, subtract, we end up with -6.44 approximately. So this one we had to use the calculator. Now we know how to do chain rule. We could do this one by hand. But this one we didn't know how to do chain rule yet, but we could just put it in the calculator and come up with a final answer. C, this one is product rule because it's f of x times g of x. And so when we're trying to find, they have it as s of x, it would be f of x, g prime of x, plus g of x, f prime of x. and we're trying to figure it at 4 for this one. And so it's f of 4, g prime at 4, plus g of 4, f prime at 4. And again, f prime at 4, that would come from the calculator again. This one ends up being 25.46. And then part D is a quotient. So it's saying T of X is f of X divided by G of X. So then T prime of X is going to be low times the derivative of the high minus the high times the derivative of the low all over low squared. And they want us to figure this at 6. So let me just put in 6 for all of our x's there in our quotient outline. And we get the value at 6, which ends up being negative 6.483. But this question was a good one of, we don't know what f of x, well, we know what f of x is, but we don't know what g of x is. We don't know what f prime of x is, but we can use the tools that we have to evaluate each of those, substitute them in, and get a final answer.